Hello everybody watching akssy to make things easy YouTube channel. Today I am going to solve two problems in physics under the title projectile motion. The first problem which I am going to solve for you says that two projectiles are launched from ground level with the same initial speed. The maximum height h1 reached by projectile 1 is twice the maximum height h2 reached by projectile 2. If θ1 and θ2 denote the respective launch angles as measured from the horizontal, these angles satisfy which of the following relationships? A. Cos θ1 is equals to root 2 times cos θ2. B. Sin θ1 is equals to root 2 times sin θ2. C. Tan θ1 is equals to root 2 times tan θ2. D. Sin θ1 is equals to 2 times sin θ2. To understand the problem well, let's read the problem slowly so that we can understand it. It says, two projectiles are launched from ground level with the same initial speed. In this statement, we are given that the number of projectiles involved in the motion are 2. The second given in this statement is the position of departure of both of the projectiles is the ground level, not from other height else. Third given in this statement, the initial speed of both the projectile is the same, which means if v01 denotes the initial speed of projectile 1 and v02 denote the initial speed of projectile 2, then v01 is equals to v02. Let's come to the second statement of the problem. In this statement, it says the maximum height h1 reached by projectile 1 is twice the maximum height h2 reached by projectile 2. This means h1 is equals to 2 times h2. In the third statement, if θ1 and θ2 denote the respective launch angles as measured from the horizontal, these angles satisfy which of the following relationships? In this statement we are given θ1 and θ2 are the respective launch angles of projectile 1 and projectile 2 as measured from the horizontal. So let's write solving the problem by writing down all the givens and the required quantities as follows. As a given we have the type of motion which we are dealing with is projectile motion. 2. The number of projectiles incorporated in our problems is 2. Third, the departure position is the ground level. Fourth, the initial speed of the two projectiles is the same. Fifth, the maximum height reached by projectile 1 h1 max is equals to 2 times the maximum height reached by projectile 2. Required relationship of θ1 and θ2. Here the diagram indicates or reveals everything in the problem. V01 indicates the initial velocity of projectile 1, V02 indicates the initial velocity of projectile 2, θ1 indicates the angle of departure of projectile 1 as measured from the ground, θ2 indicates the angle of departure of projectile 2 as measured from the ground. Everything or every line drawn by orange color is associated with the motion of projectile 2, and everything or every line drawn by blue color are associated with the motion of projectile 1. Here, the green line at the bottom of every line indicates the ground level. The vertical line drawn by blue color here is the maximum height attained by projectile 1, and here similarly the vertical height drawn by orange color indicate the maximum height attained by projectile 2. Now, before I proceed to the solution directly, I want you to remind the following sets of equations as they are very important in solving problems in motion in two dimension as well. These sets of equations, which are well known in one-dimensional motion for uniformly accelerated motions, are the following. The first equation is v final square is equals to v initial square plus acceleration times time. The second equation, displacement is equals to v average times time, where v average can be rewritten as v final plus v initial over 2 for constant accelerated motion. S is equals to ut plus 1 over 2 at square. V final velocity square is equals to initial velocity square plus 2 accelerations times displacement. S is equals to ut minus 1 over 2 at square. These five equations are equation of motion in one dimension for constant or uniformly accelerated motion. So these equations are very important equations that enables us to solve every problem in motion in one dimension. These equations are often referred to as Suvat equations, but don't forget that they only apply if the acceleration of the object is uniform or constant. The term Suvat stands for final velocity, initial velocity, displacement, accelerations, and time as mentioned here. Comparing all the givens and the required quantities in the problem with the five sets of equations, we choose v final square is equals to v initial square plus 2 times acceleration times displacement is the best match for solving our problem. So, in place of s, we can substitute h because the motion is vertical, so the distance is or displacement is vertical displacement, so we say h or height. A is equals to minus g because as objects go away from ground level towards the sky, the gravitational force of attraction on objects decreases. For this reason, we use negative g in place of g. Initial velocity is given to be v naught sine theta by decomposing the initial velocity of the object which is given into the vertical component because we are given only the vertical component of the motion. Substituting equation 2 into 1, we have v final square is equals to v naught sine theta the whole square minus 2 times g times h. So at maximum height, v final is equals to 0. So substituting 0 in place of v final and solving for h max, we have h max is equals to v naught sine theta the whole square over 2g. And we are given that h1 max is equals to 2 times h2 max. Okay. By substituting all the corresponding values of equation 4 into these equations, we have v naught sine theta 1 the whole square over 2g is equals to 2 times v naught sine theta 2 the whole square over 2g. So, cancelling out all the common terms in both sides of the equations, we have got sine theta 1 the whole square is equals to 2 times sine theta 2 the whole square. So, taking the square root of these equations, we find that sine theta 1 is equals to root 2 times sine theta 2. Therefore, choice B is the correct answer. Problem 2 says that a car accidentally rolls off a cliff. As it leaves the cliff, it has a horizontal velocity of 30 meters per second. It hits the ground 60 meters from the shoreline. Calculate the height of the cliff. Here, to solve the problem, let's identify all the given and the required quantities. In the first statement, we are told that only the presence of rolling of a car. In the second statement, it says, as it leaves the cliff, it has horizontal velocity of 30 meters per second. So, initially, the rolling car had 30 meters per second of horizontal velocity. So, the horizontal velocity of the rolling car at the initial condition is 30 meters per second. It hits the ground 60 meters from the shoreline. This means that the rolling car, landed at the bottom level of the cliff, going away 60 meters from the shoreline of the cliff. So the range is 60 meters. Here we are told that the car was rolling. So since it was rolling, it had not vertical component velocity at the initial state. So v naught y, or the velocity of the rolling car in the vertical component at initial time is 0. The required is the height of the cliff. This diagram reveals everything mentioned in the problem. The straight line drawn vertically here by black color represents the height of the cliff. The rectangular shape here represents the cliff. This black line, which is drawn in slant manner, represents the motion of the rolling car after it leaves the cliff. This distance, horizontal distance, from the shoreline to the landing point of the car at the bottom level represents the horizontal distance or range. The blue lines, which are drawn here, represents the bottom and top level of the cliff. The top line also represents the horizontal velocity of rolling car at the initial condition. The 5 equations of motion that we mentioned earlier, the one which best fits our problem is S is equals to ut plus 1 over 2at square. And substituting all the corresponding values to this problem, we have h cliff is equals to v naught y times time plus 1 over 2 gt square, where g substitutes acceleration in the original equation, and v naught y substitutes the initial velocity, but here we do not v naught y because the motion of the rolling car as it leaves after it leaves the edge of the cliff is downward. So even though it is not downward, we split it or decompose the motion into dimension. But when the car was at the edge of the cliff, before it leaves, its initial velocity along the y-axis is 0. So since initial velocity in the vertical direction is 0, v naught y is 0, and hence this quantity v naught y times time becomes 0. So we get this value. Height of the cliff is equals to 0 plus 1 over 2 gt square. Substituting all the values, we have 1 over 2 times 9.81 meter per second square times 60 meter divided by 30 meter per second, the whole square. This is because the time of flight of the car is determined from the horizontal component of the motion, because we have R is equals to the original formula for R is R is equals to V horizontal times time. So the time of flight can be calculated by dividing the range by the horizontal velocity. So here we are dividing the range 60 meters by the horizontal velocity of 30 meters per second. 30 meters per second. So when we substitute all these values, the result becomes height of the cliff is equals to 104.5 meters.